Hey everyone, if you're watching this video, you're probably wondering, should I become an AI engineer or a data scientist in 2026? Or maybe you're asking yourself, what's even the difference anymore? Well, here's the truth that nobody's talking about. These two roles have completely diverged. They're not the same thing, and choosing the wrong path could cost you years of your career. In the next few minutes, I'm going to break down exactly how AI engineers are different from data scientists. And more importantly, I'll give you the complete roadmap of what you need to master to become a rockstar AI engineer in 2026. So if you're serious about riding the AI wave and not getting left behind, stay with me. This is going to be information-packed, and trust me, you'll want to take notes. All right, let's start with the big picture. Look at these numbers. 150% job growth for AI engineers. That's not a typo. That's explosive growth. But here's what's really happening. We've moved past the wow, ChatGPT can write poetry phase. That was 2023. We're now in what I call the era of systemic orchestration. Companies don't want cool demos anymore. They want production systems that can handle millions of users, make money, and not hallucinate your customer data into oblivion. And look at this. AI engineers are earning an 18.7% salary premium over regular software engineers at the senior level. Why? Because they're solving hard problems. They're the ones building the cognitive infrastructure that's going to power the next decade. This isn't hype. This is the industrialization of intelligence, and you're watching it happen in real time.
Now, here's where it gets interesting. A lot of people think data scientists just became AI engineers. Wrong. What actually happened is something I call the Great Divergence. These roles split into two completely different career paths. Look at the left side, the data scientist. They're focused on insights, research, and decision-making. They're the why people. Why did sales drop? Why are customers churning? They work in notebooks, run A/B tests, and their output is a report or a dashboard that helps the business make strategic decisions. Now look at the right, the AI engineer. They're the builders. They take AI models and turn them into scalable, production-ready systems. Their output isn't a PowerPoint. It's an API serving millions of requests. It's an agent that autonomously handles customer support. It's real software that generates real value. Same starting point, completely different destinations. And here's the kicker. Both roles are thriving. This isn't about one replacing the other. It's about specialization. Let's give data scientists their due. This role is far from dead. In 2026, the data scientist has evolved into research scientist or decision scientist. They're laser-focused on answering business questions through data. Their core responsibilities, insight generation, turning raw data into strategic recommendations, hypothesis testing, running rigorous A/B experiments, statistical analysis, and I mean deep statistics, probability theory, causal inference, significance testing. This is not a role you can fake your way through. The math requirement here is high. If you're someone who loves digging into why things happen, if you enjoy the scientific method, and if you're comfortable living in Jupyter notebooks, this might be your path. But, and this is critical, they're not deploying production systems. They're not worried about latency or uptime. Their battlefield is different.
Now let's talk about the AI engineer, the role that's absolutely exploding right now. This is where I want you to pay close attention, because if you're watching this video, there's a good chance this is the path you should be on. AI engineers are system architects. Their job is to take pre-trained models like GPT-4, Claude, or Llama and integrate them into reliable, scalable products. They're building the last mile of AI. Look at these responsibilities. System integration, making models work at scale. Full stack AI. They need to understand everything from the user interface down to the inference server. Performance optimization, because if your RAG system takes 10 seconds to respond, users are gone. And reliability engineering, building guardrails so your agent doesn't go rogue. This role is unique because it combines traditional software engineering with AI intuition. You need to understand distributed systems and how to wrangle a hallucinating language model. It's hard, it's rare, and that's why they're paying premium salaries. Let me make this crystal clear with a direct comparison. Primary output. Data scientists produce reports and insights. AI engineers produce APIs and production systems. Tools. Data scientists use Jupyter, Pandas, Tableau. AI engineers use Docker, Kubernetes, and orchestration frameworks like LangGraph. How do they measure success? Data scientists look at accuracy, AUC-ROC, p-values. AI engineers care about latency, throughput, and cost per token. Math requirements. Data scientists need advanced statistics. AI engineers need linear algebra and discrete math, important but different. And here's the big one, growth outlook. Data scientists have stable growth at 26% CGR. AI engineers, hypergrowth. We're talking 150% plus, driven by every company on Earth trying to integrate AI into their products. Do you see the difference now? Same industry, completely different skill sets and career trajectories.
All right, now we're getting into the practical stuff. If you want to become an AI engineer, what do you actually need to learn? Two critical pillars, Agentic AI and Advanced RAG. Let's start with Agentic AI. In 2026, we're not building chatbots anymore. We're building agents that do things. But here's the catch. Fully autonomous agents are unreliable. They loop, they hallucinate, they break. The solution? Agentic workflows. You need to master frameworks like LangGraph, which lets you build agents as state machines with deterministic control flow. This is what separates toy projects from production systems. Now, RAG, Retrieval Augmented Generation. If you're still doing naive RAG with basic chunking and cosine similarity, you're already behind. The 2026 standard is hybrid search, combining vector search with keyword search, and contextual retrieval, where you pre-process chunks so they're self-contained and semantically complete. These aren't buzzwords. These are the techniques that separate junior engineers from senior engineers. Now let's talk infrastructure, because here's something most people don't realize. Python is not enough. Don't get me wrong, Python is the lingua franca of AI. You need it for orchestration and data work. But when it comes to high-performance inference, Python's too slow. Enter Rust. In 2026, Rust has become the language of AI infrastructure. The industry-standard inference engine, vLLM, is built with Rust and high-performance kernels. If you understand vLLM's paged attention algorithm, you're already in the top 10% of AI engineers. And here's a huge trend, edge AI. Companies are moving inference to the edge, running models directly on user devices using WebAssembly. Why? Privacy, latency, and cost savings. Technologies like Transformers.js let you run models in a browser. This requires understanding model quantization, compressing models to N8 or GGUF format so they're small enough to download. If you want to reach staff or principal engineer level, you need to understand this infrastructure layer.
Okay, let's address the elephant in the room. Everyone's saying, with AI coding assistants like Copilot, do we even need to know algorithms anymore? Here's my answer. Yes, but differently. Top tech companies, Meta, Amazon, Google, OpenAI, they're still doing algorithm interviews. Not because they care if you can reverse a linked list, but because they're testing your problem-solving stamina and your ability to reason about computational complexity. But here's what's changed. The interview focus has shifted to AI system design. Instead of design Twitter, it's now design a RAG system for millions of documents, or design a distributed training cluster. You need to understand things like vector indexing, HNSW graphs versus IVF indices. You need to know the difference between O of n linear search and O of log n approximate nearest neighbor search, because that's the difference between a demo and a production system. Bottom line, If you treat vector databases as black boxes, you'll never scale your systems. Understanding algorithms gives you the mental models you need. Let's talk money, because this matters. AI engineers earn more than regular software engineers. At entry level, it's about a 6% premium. But at staff level, 19% premium. We're talking six-figure differences in total compensation. Why? Scarcity. The number of people who can bridge distributed systems, machine learning, and product thinking is tiny, and every company is fighting for that talent. I remember that 150% job growth we talked about? That's not slowing down. Every SaaS company, every enterprise, every startup is racing to integrate AI. They need AI engineers, and they need them now. If you're on the fence about investing time to learn these skills, let this be your motivation. The market is screaming for this expertise.
All right, you're convinced. You want to become an AI engineer. What's the actual roadmap? I've broken this into 4 phases. Phase 1, months 1 to 3, foundations. Master Python, specifically async I/O and Pydantic. Brush up on linear algebra and maintain LeetCode medium proficiency. Understand the transformer architecture and how embeddings work. Phase 2, months 4 to 6, orchestration. Deep dive into LangGraph. Build a stateful agent. Implement a hybrid RAG pipeline with re-ranking. Move beyond prompt engineering to frameworks like DSPY. Phase 3, months 7 to 9, production. Learn to deploy vLLM. Experiment with model quantization. Build evaluation pipelines using tools like Ragas. Master Fast API for serving agents. Phase 4, 10 months plus, specialization. Fine-tune models using Axolotl. Start learning Rust. Experiment with Edge AI and WebAssembly. This is a 12-month journey to go from beginner to job-ready. It's intense, but it's exactly what the market demands. Here's the truth that ties everything together. AI hasn't made coding obsolete. It's made coding more critical. The focus has shifted from syntax, which AI can handle, to system design, reliability, and orchestration. The engineers who succeed in 2026 aren't the ones who can prompt ChatGPT. They're the ones who can build intelligent systems around it. Master agentic workflows. Build hybrid retrieval systems. Treat evaluation as a first-class citizen. The opportunity isn't in the model itself. It's in the system you build around it. And remember, data scientists and AI engineers are both crucial. This isn't about one being better. It's about choosing the path that aligns with your strengths and interests.
Look at this. This is you, the rockstar AI engineer of tomorrow. You're a systems thinker. You're production ready. You're always learning. You're the person who's going to build the intelligent infrastructure that powers the next generation of applications. You're the one who's going to solve the hard problems that matter. The tools are here. The demand is here. The opportunity is massive. So here's my challenge to you. Start today. Pick phase 1 from that roadmap. Write your first LangGraph agent. Deploy your first RAG system. Build something, break it, and build it better. Here's something important I want to share with you. I'm going to teach these topics at exactly the depth you need to pass interviews. Nothing more, nothing less. Because I know your time is precious. Look, I've noticed a trend lately. A lot of software engineers are jumping into AI engineering content on YouTube. And here's the problem. They focus heavily on the engineering side, Docker, Kubernetes, deployment, which is important, but they miss the AI fundamental part, which is equally important. You end up spending months learning, but you're not interview ready because you're missing half the picture. That's not going to happen here. On this channel, you get the perfect balance, the engineering skills and the AI science. Both are non-negotiable if you want to land these roles. So if you're serious about becoming job ready, not just learning random topics, hit that subscribe button. Let's build your AI engineering career the right way, together. And if you found this valuable, do me a favor, smash that like button, subscribe to the channel, and drop a comment telling me which path you're choosing. data scientist or AI engineer. The future of AI is being built right now, and you get to be part of it. I'll see you in the next one.